Rain is falling with a speed of 25 meters per second at an angle of 20 degrees to the vertical. A car is travelling along the horizontal road into the rain. The windscreen of the car makes an angle of 32 degrees with the vertical. This car is travelling at 20 meters per second. Find the angle at which the rain will strike the windscreen. So guys, what we're going to deal with is we're going to keep it to what we know. X-axis, Y-axis and J-axis. Very important that you keep it that way. Okay? Now, what happens is it falls 20 degrees to the vertical. So if this representing the rain, okay, and this here is representing the vertical. So what we can say here is that this here is 20 degrees, okay, and then if we draw it right down, up and down, okay, break it into its components. It's going 25 meters per second. The rain is falling at, okay. So let's do 25 cos 20. Is 25 cos 20 is the I component. Anybody know what that is? 25 cos 20?
It's like 28.55.
Yeah, I think so actually. 23.49, yeah? Okay, so it's 23.49. Okay. So that's...
Just ignore me.
Okay, so this is 23.49, okay? So the other one is 25 sine 20. Okay, so you put that into the calculator, 25 sine 20. 8.55, okay? So that's 8.55. So what we can do now is we can break this down into the velocity of the rain. Phi r is going to be 23.49. That's 23.49 across to the right and going down at 8.55 J. Okay? Now, so I'm just going to check 25 cos 20 again. Just want to double check it. Seems a bit small.
No, it's right.
23.49. Oh, it was sine, wasn't it? Ah, sorry, I got these mixed up. As in, it's 8.55 across. Excuse me. 8.55 is the I, and the J is minus 23.49 J. So you got to make sure that it's in the right direction. Okay, velocity of the car. It's going. The car is going into the rain. So if the rain going to the right is positive, the car going to the left is negative. So the car going is minus 20i. Now, what it says is find at what angle does the rain appear to strike the windscreen? The wind, yeah.
Why do you pick the angle with 20? It's in your diagram.
What happens next is once we do this, okay, minus 20, we're going to get the velocity of the rain relative to the car because the windscreen is an object that belongs to the car, okay? Now, what happens there is it's going to be phi r minus phi sig, okay, which is going to be 8.55i minus 23.49j, and then we're going to have minus bracket minus 20i. Add them together, we're going to get 28.55i, and we're also going to get minus 23.49j, okay? Now, what this means is, if the car was a flat object, okay? So if the car was a flat object, and we kept the car as an entity stationary, we've now found the velocity of the wind relative to the car when the car isn't moving. So if we put it like this, that now it's coming down at this angle here. I know this because it's across 28.55 and down 23.49. To find this angle x, I'm going to tan inverse, 28.55 divided by 23.49. And what do we get? 50.55. Okay, so x is 50.55. Now, the problem is that this 50.55 represents what it would be doing if it was hitting the top of the car, not a slanted edge of the car. So this is where you're bringing in your knowledge of the 32 degree angle, okay? So what happens is I can draw my 32-degree angle of the car, like so. So that's going to represent the windscreen, okay? So what we're going to do is going to take this here and move it up along the screen, okay? Now we want to find the angle it makes with with the windscreen, isn't it? Okay, so just give me a second here. So we don't need those numbers anymore. Okay, so this here is 32, isn't it? Yeah?
58.
Sorry? The windscreen itself. It's 32, correct? Okay, and we want to find the angle at which the rain appears to strike the windscreen. Okay, so the answer is the 82. Okay, so it's this angle here is what we're looking to find out. Okay, now you could technically argue there's two answers there, isn't there? Just the obtuse angle and the acute angle that hits the windscreen at. Okay, so you could put down both to cover yourself in the test. Now, how do we land that? Alright, so that's 50.55 here. Okay, and that there is going to be 90. Yeah, what angle is this going to be in here? This angle here. 180 minus 90 minus 55.55. Sorry? 39.45. Yeah. Okay. Take that away from 180 and you get 50 points. What do we get there? 50.55, is it? Oh, sorry. That there is 32, isn't it? Why does that be 32? Sorry? Z. Okay? Yeah. So we're just going back up the top here, right, just to double check what we had a second ago. So that's 32 there, which makes this angle here 58. Okay? So that's 32, that's 58, which makes this angle here 58. Is everybody agree with that? So just come back down to what I had earlier. That's 58 there. Okay, and I had my rain hitting at an angle from up here, didn't I? And what was the rain angle again? 50.55. And we figured out that this here was 39.45. Okay, this here alternate angle has to be 58. Yeah. Now, there's two angles. Okay, this one here is technically an angle with the windscreen, and the answer for this one would be 39.45 plus 58, which is 97.45. And then we have the other angle, which is the angle I think they're talking about in the solutions, where it's 180 minus 97.45, and we get 82.45, is it? 55. Okay, and that's our answer there. Okay. Okay, so just make sure not to get mixed up the 58 degrees there, okay? Now, moving on, which is this one here. Okay, we'll just so what happens is a ship A is traveling southwest at 24√2 kilometers an hour. A ship B is traveling due west at 17 kilometers an hour. Find the magnitude and velocity of A, B relative to A. We want to find phi BA, which is phi B minus phi A. Okay? Now, the great thing about this is we figure out what is southwest. It's down and to the left. Okay? So, southwest, this direction here. And it has two components. Its south component and its west component. 45 degrees no matter which angle you take. okay, and it's going to be 24 root 2. So we have to find out what 24 root 2 sine 45 is. I'm pretty sure it's just going to be 24. Okay, we'll see now. 24, okay, that's 24, and that one's going to be 24, okay. It's going down and left. This means that the velocity of ship A is going to be minus 24I minus 24J, okay, and so that's our velocity of A. Now, ship B is travelling due west. Now what about due west? Velocity of B is going to be minus 17I, going directly to the left, okay. Now we're going to do velocity of B relative to A, okay. We get phi B minus phi A, okay. And what happens next is we're going to put this in, and what we get is phi B minus phi A, okay. So we're going to get phi B minus phi A, so it's going to be minus 17I minus bracket minus 24I minus 24J, close bracket, and what we're going to get here is 7I plus 24J. Okay, we're currently at only 5 marks. Okay, now find the magnitude and direction. I didn't find the magnitude, nor did I find the direction. So the magnitude, this basically means that we're going 7 to the right and 24 up. Do Pythagoras' theorem. Find out what it is. It's going to be the square root of 7 squared plus 24 squared. And what you get there is 25. Okay? Now it's very important you label it. The magnitude of V relative to A is 25. Okay? Next part, the angle. Okay? What is angle X? So tan X equals 24 over 7. So tan inverse 24 over 7. And what you get? 73.74. Okay? So X equals 73.74. Now, that's, once again, I don't think that's going to get you the full marks either, because I don't think we're exactly mentioning, I'd mention southwest as well. I'd say the direction, so I'd actually say this. I'd say east, 73.74 degrees, north. There's another way of saying that, isn't it? North, take 90 away from 90 minus that, east. Okay, same way of saying it. Okay, now that I've done that, what goes is A and B can exchange signals when they are no more than 20 kilometers apart. At what time can they begin to exchange signals, and how long can they continue to exchange signals? Okay, so what we're going to need now is, I can get rid of all this here. Okay, so just this here is used information. There's no more use for it. Okay, so just rub it out. Okay, we also don't need this information here, because we got our angle and we have everything we need to know in this bubble here. Okay, so we'll just you'll just keep that to the side for when you need it. Okay, and then we're going to go up and we're going to see about this question here. Now, first things first, you should probably write they're starting off. Now, what velocity of B relative to A means is that A is kept stationary in comparison to B. Okay, so what we're doing, we're going to draw our initial diagram. It's ship A is 40 kilometers north of ship B. So you're going to ship A up here and ship B down here. Now, what we're told is it's the velocity of B relative to A. You happy with that? So B relative to A, I'm going to put this in a dotted line. It's going to go up this way. Remember, across 7 up 24. So it's going to go all the way up there, like so. Okay? This is 50 kilometers at the start. Okay? When it's at 90 degrees, okay, that's when it's at its closest point. But we don't want its closest point. We want to figure out when is it actually going to be within 20. So we're going to put in the 20s here. 20 kilometers will be somewhere in here, and then there'll be another 20 out here. Okay? So what we got to do next is we got to figure out some angles. We know that this angle here is what? We know that here is 73.74, 90 minus that. 16.26. Okay, so we got our 16.26 in here now, okay? Now, what else do we have to find out? Okay, at what time can they begin to exchange signals? Okay, here's what we're going to do. We're going to find out the length of here. Sorry, we're going to find out the length of here to here. How would you do that? It's the adjacent, isn't it? So you're going to say cos 16.26 equals, it's going to equal x over 50, yeah? And then figure out x is, what's 50 cos 16.26? Anybody know? On the dot, is it?
Pretty much.
Okay, just give me a look at it. 16.26. Just want to make sure I don't do any round up. Yeah, sorry for doubting you. 48 exactly, okay? So, guys, 48. Now, 48 is the full distance. But if you, so that's 48 is the full distance across, isn't it? Okay? And, let's see what I should have done now. The 48 isn't actually relevant information at all, because the 20 belongs to the hypotenuse of this right angle triangle here. So what we should have actually done was found the sine version of it. So we're just going to rub this out, and we're going to put in sine instead. So you can just change cos with sine, okay, and we'll find out what the other side is. So what's sine? 14, okay. Now we can look at this triangle in here, can't we? Actually, we did need the 48 after all. It's going to come in useful now in a second. Pythagoras' theorem, find out what here to here is. Okay? So it's going to be x squared equals 20 squared minus 14 squared, and square root the answer. Okay, Jack? Shouldn't be into it. 20 squared minus 14 squared, and square root the answer. 2 root 51. Good job. Now, 2 root 51 is this distance here. Okay? So, what we can next say is that it goes, at what time then can they begin to exchange signals? Now, what time did they leave at? Does it say what time they leave at? Just how many seconds, is it?
At noon, should say.
At noon, so 12 o'clock. Okay? So what we're going to do is we're going to get our 48. So the distance we need to travel is 48 minus 2 root 51. So distance over speed. Now, distance is 48 minus 2 root 51. And what speed can we do? It's our magnitude. 25. What you get for that?
1.34.
1 point?
349 or 3486.
3486 or 87, so 1.349 hours, yeah? Now, funny thing about that is there's a button in your calculator that does it very nicely, alright? So if you were to do this here, alright, all in the calculator, the degrees and minutes button does it absolutely perfect. So look at this, divide by 25, and then you get this number here, okay? You go, okay. But if you press this button here, 1 hour, 20 minutes, 55 seconds. 1 hour, 21 minutes. Okay? So it's going to be 1 hour and 21 minutes. And what can we say about that then? It's going to be 1 p.m., isn't it? Or you want to do it on 24-hour clock? 13, 21. Okay? Next part. How long can they continue to exchange signals? Now, continue to exchange would mean we're starting here and we're ending here. Now guys, it's 2 root 51 this far. How long would the full thing be? 4 root 51, okay? So what we're going to do is we have a triangle here. Like so. One of the lengths is 4 root 51. We also know that this here is 20 and 20. But also we needed to know distance, wasn't it? So it's going to be 4 root 51 divided by 25. Into your calculator. 4 root 51 divided by 25. And what we get here is 1.14. Press the change button. 1 minute, 8 seconds, and 8 minutes and 33. Yeah. Do you know what? If I was in a test, I'd say 1 hour, 8 minutes, 33 seconds, and then I'd put underneath that 1 hour, 9 minutes. Does it say to the nearest minute or anything like that? No. So that's perfect, okay? Alright guys, so that is 2000 and